here are the limit laws for limits. Suppose that c is a constant and the limit as x approaches a of f of x and limit as x approaches a of g of x exist, then this is true. I already went over this one limit law where you can factor out a constant. So if you got a constant in front of f of x, you can factor it out. Kind of like limit as x approaches a of c times f of x. You can factor out that c. Let's see here. The limit as x approaches a of f of x plus g of x, provided that the limits exist for each one of them. Is that what it says? Let's see. So basically, it's kind of, I don't know if it's correct to say it, but you can just distribute that limit into each. So it'd be limit as x approaches a of f of x plus limit as x approaches a of g of x. And it would be the same for subtraction too. I could have put a minus in between and then it would be the same. I don't know if you want to write it twice, but it's basically the same. It would be also the same with multiplying. If you multiply two functions, so the limit as x approaches a of f of x times g of x, and you can distribute that limit into each. Division as well. The limit as x approaches a of f of x over g of x, and I just said before, you can just, we done it the other day. You can do the limit as x approaches a of f of x over limit as x approaches a of g of x. In this one, the limit as x approaches a of f of x to the power of n. I don't know, this kind of, I don't even know why I have it here, because there's other ones that are as weird as this limit law, that you can go in, you can distribute that limit as x approaches a inside of the brackets here. But more so, we're just going to do these problems, and whenever these come up, we will do those limits appropriately for whatever problem we got. But let's go ahead and get started. Let me give you another minute, maybe to write this down. And if you don't, you told you go to the website, and you can get all the notes. All right, moving on. So go ahead and I don't know. This is the one that's just going to take the most time. If you didn't go already to the website and copy down the graphs, I could have printed this out and then had you glue it on one of the pages of your notebook, but I didn't do it, so now you're going to have to copy this down. Because I am recording this, I'll give you time after to copy this down. So I don't know, leave some space, or it shouldn't take too long. Copy these two graphs down, and then we're gonna do some problems. If not, just look at it, look up there, and we're gonna start doing some problems here. And then you can copy it down later, if you haven't done so already. So, write down problem number 1. So we can start doing this. Okay, so look, like I just said, look, you can go back and copy this down later on the graphs. But let's go ahead and write this down, problem number 1, and let's start doing this problem. You know, the limit will be distributed. Maybe it's wrong to say that, but yes, we're going to put the limit. And also, we can factor out the 3 for this one. So, yes, let's go. So this answer is going to be 3 times the limit as x approaches 5 of f of x minus, and I'm also going to factor out the 2, minus 2 the limit as x approaches 5 of g of x. So I'm doing like 2 properties already of the limits already to do this. All right. Let's see here. Don't say anything. Let's see who's that. By looking at the graph, Skyler, what's the limit as x approaches 5 of f of x? Limit as x approaches 5 of f of x. The first graph is f of x. The limit as x approaches 5 of f of x. This is f of x. This graph is f of x. This other graph is g of x. So we're looking at the first graph. So what's the limit as x approaches 5 of f of x? Which side? Loud, what? Are you saying negative 2? What are you saying? Brian, help her out. What's the limit as x approaches 5 of f of x?
3.
I don't know, but we've done this too much already. Aren't you getting on the car? And limits is that you are actually driving it. You're driving and you're driving towards and it's the y value is the limit.
I was looking at negative 5.
What is it, everybody? What is it? It's 2. So 2 times 3 minus 2 times the limit as x approaches 5 of g of x. Hold on. Grover. Limit as x approaches 5 of g of x. 4. Yes? Everybody, we got this 4? And this is just basic math. 3 times 2 is 6, minus 2 times 4 is 8. 6 minus 8. What's 6 minus 8? Anybody? Negative 2. Okay, so there's that. So we're doing this, and that's all we're doing here. We're using the limit laws. So let's go on to number 2. So learn also, you have to be proficient at knowing how to read what it's saying. This is saying what is the limit as x approaches 3 from the right side. That's plus. So what's the limit as x approaches 3 from the right side of each one of these functions that are added up? So I just kind of say that they're added up. You distribute the limit. So it's going to be the limit as x approaches 3 from the right side of f of x plus the limit as x approaches 3 from the right side of g of x. All right. So what's the limit as x approaches 3 from the right side of f of x? Don't say anything again. Now, Natalie, what's the limit as x approaches 3 from the right side of f of x? The limit as x approaches 3 from the right side of f of x? Loud. Hey, you guys talk to each other for, let me give you 30 seconds. Talk to somebody. You guys talk to each other. Something is, what is the limit as x approaches 3 from the right side of f of x? Talk to somebody. Let's give you 30 seconds. You, Brian talking to her, or is that at least somebody in there talk to her? You talked to her?
I don't know what the question was.
What? No, you talked so you can help her out. The question was limit as x approaches 3 from the right side of f of x until you have talk.
For the first graph, right?
That's what did f of x, and this is the other one g of x. I already said that. But it was Natalie. You talked to Natalie.
Yeah, fine.
But no, okay. So Natalie, what is it? Huh? Louder. It's 6. Yeah, I don't know what else to say. When you're talking about limits, you're actually getting on the car and you're driving. If it's possible, you're driving towards it, and then what value are you approaching? It's 6. Is it defined or not defined? It doesn't matter if it's defined or not. It's that you're getting closer and closer and closer to 6. Huh? All right. 6. What's the limit as x approaches 3 from the right side of g of x? Andrea. Andrea, what's the limit as x approaches 3 from the right side of g of x? Yeah, it's 8. It's 8. Okay, so yes, all right. For people that are getting confused, you got to look at the correct graph. It's telling you right here this is f of x. It's telling you this was g of x. And so you got to know which one you're looking at. So this is 6 plus 8 is 14. The answer is 14. All right. Let's go. All the way through, let's go ahead and give me the answer to that. And I'm just going to ask you. Let me give you about a minute. Do number 3. Look up here to this graph, because sometimes you copy it down and you mess it up because you're not copying it down correctly. So this is right here is correct, the graph up here. So be looking up here. What is the limit as x approaches -5 from the left of f of x minus g of x? What's the whole answer, Aiden? What's the answer? The whole thing? Huh? So 3. Yeah. Yeah, no? Yes, yes. Everybody? Yeah? Is that good? All right, so -1. All right, good. Everybody, yes or no? Got it? So moving on. Let's go to number 4. Yeah, do go ahead and actually write down that the limit is kind of distributed in. Let's go ahead and write down what it is that we're doing here. So this is going to be the limit as x approaches -7. Factor out the 3 already, so we're going to factor out the 3. So 3 limit x approaches -7 of f of x. And then we got limit as x approaches -7 of g of x. All right. Okay, so the top. Leonardo, who's the answer to the top, the whole thing? No, but the whole thing. Do everything. What's the answer for the whole thing? Yes. Well, it is. You did get it right, but finish it. You got the limit. You did do limit as x approaches -7 of f of x is what? Negative. And that's f. This is f. Huh? No. The answer to here. What are you supposed to do?
15.
Yes. Yes or no, everybody? You could complete the whole thing. So it is 15. 15 on top, no? And what's the answer at the bottom? Becky. Three. And so the final answer is what? Everybody? 5. So yes, we could have just canceled out right there, and it's 5, whatever. Okay, let's go. Moving on. Now number 5. Isn't that the last limit law that we had covered? We had talked about in the beginning. We can go ahead and distribute that limit inside of the brackets. So then this is going to be what? Limit as x approaches -3 of this f of x, and then square it. So what's the answer, everybody? What's the answer? What's the answer? 36? 36? The limit as x approaches -3 of, you got to work this out. What's the limit as x approaches -3 of f of x? -3 is going to be 6. So then you go 6 squared is 36. Did I say 6 or is negative 6? It's negative 6 squared. Yes? Negative 6 squared, yeah. All right, here, number 6. Let's go to number 6. Now it's getting a little bit weird. This is a composite function. You guys do remember this is going to be a big one here. This is a composite function. The limit as x approaches negative 2 of f of g of x. So we can go ahead again, put it in there. So this is going to go f of lim x approaches negative 2 of g of x. Yes. So that is true. All right. What's the limit as x approaches negative 2 of g of x? Hold on, don't say anything. Limit x approaches negative 2 of g of x. Evelyn, negative 3. Negative 3. So limit x approaches negative 2 here of g of x, this g of x, and we're approaching negative 2, it is negative 3. So now we got f of negative 3, okay? What's f of negative 3, everybody? F of negative 3? Negative 6. Yes? F, the output of negative 3, now we're just doing the output of negative 3. F of negative 3 is negative 6. Yes? All right. Number 7. Yeah, let me see. So we had this number 7, and we are going to do this limit laws. We are going to apply it, limit x approaches negative 3, and we do have f of x, and we're going to add lim x approaches negative 3 of g of x. Okay, so lim x approaches negative 3 of f of x, limit as x approaches negative 3 of f of x. And that is, we just did it, right? Negative 3? Negative 2, negative 3? Of f? What is it? What's the limit as approaching negative 3 of f of x? Is negative 6? Yeah, negative 6. But we got a problem here. What's the limit as x approaches negative 3 of g of x? What's the limit as x approaches negative 3 of g of x? Does not exist. So this does not exist. Now what you're going to say about negative 6 plus does not exist? What's the answer? Does not exist. Does that convince you that it does not exist? Then you're like, well, what's up with this negative 6? The limit does not exist. If one of them doesn't exist and then something does, the limit does not exist. That's good enough. Let's go. Does not exist. All right, let's move on now. Okay, so moving on. Let's copy this down. So it says find the limits if the limit as x approaches c of f of x is 3, and then the limit as x approaches c of g of x is negative 2. And the limit as x approaches c of h of x is 4. Then we can work out these problems. 8. The limit as x approaches c of some square root of 3 times h of x minus 2g of x. So, like I said before, I did not go over a particular limit law like this, but just like the same as the last one I had done about brackets to a power, and then you make the limit go inside of the brackets. It's the same thing. It's not brackets, but instead of a square root, we can go ahead and distribute in the limit into each one of them. So let's do it. So then this is going to be, and I can factor out the 3 outside of the limit. So this is going to be 3 lim x approaches c of h of x minus 2 lim x approaches c of g of x. Okay, so then 3 times, what's the limit as x approaches c of h of x? Come on, what is it? 4, yes? The limit as x approaches c of h of x is the last one over there. The limit as x approaches c of h of x is 4. So it's 3 times 4. Minus 2 times the limit as x approaches c of g of x. What is this? Is that my, yeah. Limit x approaches g of x, negative 2. So negative 2. So times negative 2. So this is going to be what? 3 times 4 is 12. But negative times a negative is a positive 4. So square root of what? Which is 4. I don't know what this is. Whatever. No, that's fine. What I just did, what we did. All right. You don't have to. Number 9. Just rewrite it as square root, as a fractional exponent, whatever you did. All right. Number 9. All right. Can you do this in your head? By looking at it. What's the answer? Say it if you know it. What is it? Is it negative 30? Yes, yes. All right, let's go on number 10. Well, okay, let's go to number 10 here. This one says the limit. So we're going to distribute inside of it. So the limit as x approaches c of 7 minus the limit as x approaches c of g of x, and then the quantity to the power of 2. So what's the limit as x approaches c of 7? It's 7. Look, whenever you just have a constant, 7 is right here. Look, if I was to graph it, 1, 2, 3, 4, 5, 6, 7, and so y equal to 7 is a horizontal line. So you're driving on a horizontal line. It doesn't matter the y. It's always the y value. The y value is always 7. So whenever it's a constant, it's just 7. Yes or no? Yes. So anyways, the answer to this one right here is 7, no? So this is 7. And what is the minus? Minus the limit as x approaches c of g of x is what? What is it? Negative 2? Yes? Negative 2? Negative 2? So what's the answer? Huh? 81. 81. Let's go to number 11. Yeah, so let's you're gonna distribute to each one of these actually. So it is gonna be limit as x approaches c of h of x times the limit as x approaches c of f of x plus the limit as x approaches what's the limit as x approaches c of h of x? 4 times what? Limit as x approaches c of f of x? 3 plus what? And that's going to be what? What? 18, isn't it? Is 18? 12 plus 6, 18? What? Oh no! Oh my God! Look. Gotta be very careful about this. I gotta be very careful about this. I done it. I always do it though. I swear I did it last year too. Let's go to number 12. I'm getting a headache right now. It's because I drink too much coffee. I get migraines because I drink too much coffee. Blah blah blah. What is it? Lim inside. You know, you gotta put. What is going on here? What the heck happened? What the heck is going on? Look, you know, it's no. Why are you not writing? Look, look, everybody, look. Huh? The what? Oh, because I got the I? Yeah. Yep. This is fine. So what is it? What's the answer on top? The top. The whole thing is gonna be what? 9? What the heck? What's up with that 9? Alright, what's the limit as expression C of 4? 4 minus what? Negative 2, which is going to be what? 9 over 6, which is what? 3 over 2. All right. So hopefully you, this is good now. We got this. Oh, good. Let's do one more. Last one, because I'm done with this. Last one. I'm still drinking coffee. You know, got a headache because of it. I'm an addict. No, it's not. It's not funny. Okay, so they're giving you these values, and so you know the difference. What is for an input of 3, the output is 3, is way different than what we're saying here about the limits. The limit is something else. So know the difference between them. And the table above gives selected values and limits of the functions of f, g, and h. What is the limit as x approaches 3 of h of x times 2 times f of x plus 3 g of x in parentheses? So I really hope I better not be making a mistake like I did previously. They do matter a lot, these parentheses. So that's saying that that is together right there. All right, let's go ahead and distribute in the limit. I'm going to use brackets. So I distribute this in for this. I'm just going to keep it like the outside. And then I'm going to go 2 times limit x approaches 3 f of x plus 3 limit X purchase 3, G of X. This is okay, and this is just another way of writing it. I like this better the way I'm writing it. You don't need to put anything outside or nothing. You don't have to do all this after. That's good enough. All right. So what's the answer here? This one. What's the answer for this? What is this answer? You said what? 2 times 2 times. What is this? 2? What? I hope that we're correct. We're doing this right. And what is this? 8? What is 24 plus 4? Yeah. And that's what? 56, and it should be good. And that's, I think that's enough. We're done for today.